Hey, hi. So basically, see, so now in my updated code, what I have done, let me go through the starting. So first time I have uploaded a data set in some cat box so that we can directly download it and we can directly unzip it. Okay. So I have uploaded a data set in this site and from there we can directly download it. Okay, and we can unzip it. So that we have done, and then we have basically imported certain libraries. I believe you already aware of all these libraries and processing, as I saw your code, so it was pretty fine and accurate, right? So just using numpy, pandas for matrix calculation, machine learning operations, correct, sklearn for machine learning algorithms, all those. Okay, so then here we are loading the data set, or whatever data set we have, we are loading it into our system. Okay, and then printing some head files, and then checking some info of that our algorithm. So algorithm almost data set almost have this number of records, which is basically a huge number. Okay, and there's a description of data set which basically describe the count, minimum value, standard value, 25% value, etc. Okay, and similarly these are the number of columns having in our data set, correct. And then what we have done, I have created a function, column distribution function, which basically takes the column input, and based on column input it will analyze the value count, it will calculate the total values and plot the graph like this. Okay, suppose this is the particular label, right? So it just take the label and just plot the graph ki what is the range bound of that particular column. Okay, like that. Similarly, I have created a function for a bar graph, just like I wanted to plot ki how many number of records are there for every attacks. Okay, so just like this is the plot for the same ki DOS attack having almost 20 something 20 lakhs or 30 lakhs records, right? Similarly, this is the manual count. Okay, and similarly this one is also the same, and there's a pie chart of the same. Okay, and there is a more attractive way to it, so we can put it this in paper or a report. Okay, similarly we are dropping some replacing or dropping some duplicate values. Okay, and checking key is there any infinity value or like that. Okay, and dropping the null values too. So then we are doing the encoding, the label encoding for our labels or any other columns are there. Then it will automatically do the label encoding and it will give the number based format because algorithm will be needed numbers, right? So labels and all won't be useful for algorithm. Similarly, after encoding, this will be the our pure data. Okay, and then I'm plotting some correlation. This is a correlation graph. These the manual values, and then here is the some novelty, or we can say improvement, which I have done in our project. Okay, to get more accuracy, I have applied some engineering, feature engineering. Okay, what I have done, I have there is some sync count and acknowledgement count are there, right? Ki how many values was synced, and these are the columns. Okay, in our data set, which is having significance uh, for the particular. Basically, I have created a complete document, so you can go through this for those signification ratio columns and remaining columns. What is the use and all those. Okay, so what I have done, simply I have created the ratio ki how many counts of significant counts are there and what is the acknowledgement value of that particular thing. Okay, similarly f in rest in count. Okay, so to just get understanding of data set, to just get more valuable data. Okay, so for those purpose I have created this ratio. Okay, similarly created the total flags ki how many number of flags are there. So there are different types of input packets information are there. So what I have done, whatever flags columns are there, I have just combined and g- made it sum and added into this total flags. Okay, similarly I have created the ki how many protocols has been used in there. Okay, so that I have also added. Okay, and also added the magnitude and ratio. Okay, magnitude and radius column ratio. Okay. Similarly, I have done some outlier handling. Outlier is nothing but key. Suppose there is a data set which is having a column age. Okay, so there are thousands of records are there, right? So one record having age is one, and one record having age is 59, and remaining records having some range of 1 to 25, right? So in this scenario 59 will be the outlier. Okay, so like that, I'm identifying the outliers from our data set, and if there are any outliers then it will remove such records, such rows. Okay, because those can be affect our data set mod algorithm, correct? And I also tried the handle imbalanced data and applying some smooth undersampling hybrid. Okay, but it won't work. Okay, it doesn't help to improvise the accuracy. Okay, and I have also done the feature selection. So for the feature selection, what I have done, I have created a random forest algorithm. I have trained the random forest algorithm, and whatever the best features, top 20 features was selected by random forest. I am using that. Okay, I have tried PC as well, but it was not much accurate. Okay, as compared to a random forest. So we have used random forest. Okay, so here I am applying the all things. Okay, so first we are handling dividing data into x and y. Okay, we are taking all columns as a x input and label as a y, and then handling the outliers, and we have created the scalar. This is basically nothing but the normalized data. Okay, scaled data. Okay, and after that, after the scaled data, we have applied the feature engineering, those ratio and total flags thing. Okay, and after that, then we have uh, trained the feature selection model, random forest algorithm, to select top 20 uh, columns. So this way we have selected the top 20 columns, and then we have divided the data into training and testing. So these are the top 20 features. So one of the important one is I-80 something. Okay, and also see, we have added one column, right, total flag, which basically was highest third highest important column made. Okay, because this is something, this way we can improve, we have improvised the accuracy. Okay, and then it is the function which I have created to print the complete accuracy, FN score, recall, everything. Okay, so the first algorithm which we use, decision tree, I have done grid search and everything and identified the base parameter. And after the base parameter identification, it was the almost accuracy of 100% on training data. Okay, and testing data, it was almost 97.1. Okay, which is very pretty good accuracy. And this is the separate accuracy for all further all separate classes. Okay, similarly random forest. Okay, and this is the accuracy graph, accuracy details for random forest, similarly for knn. Okay, and then what I have done, see, still we have not achieved our purpose, right, the 99 purpose. So what I have done, then I have used the hybrid model, stacking model, where I have used random forest as a meta model and remaining three models which we have trained as a base models. Okay, and I have combined everything into stacking, and then I have trained that stack model. Okay, so there we about to got the 98% accuracy, so that we have used. Okay, so this way we have achieved the 98% accuracy. And here are the some samples, CSV sample which I have exported for the testing purpose. Okay, so this way we have, I have done the implementation. Okay, if you want to do any modification, you can do it. I have provided you Jupyter notebook. Okay, and you can do the same, or if you want, you, I believe you have also trained your own model, you can also show the same training notebook files to your faculty, or you can put it into research paper. Okay, so apart from this training data, for the front end and the web part. Okay, let me open it into Visual Studio. So you can also download the Visual Studio and unzip the given folder and open it into a particular Visual Studio. Okay. So to run the project, what you have to do, you just have to simply go to your project folder. You can open the terminal, and in the terminal you can simply write Python app.py. Okay. My team member will help you out, or I will help you out to do the setup, front end setup. And just whenever you wanted to run, you just have to run this command. Okay, then it will load the models and everything, and it will give the URL. Okay, so till it is running, let me explain you, okay, what we have done. Okay, so for the front end part, for building front end pages, login page, sign up page, we have used HTML, CSS. Okay, plain HTML, CSS. Okay, and for the backend language, obviously we have used Python language, right? And for the database, we have used SQLite. Okay, SQLite inbuilt Python database. Okay, and for interfacing front end, back end, and database, we have used Flask framework. Okay, Flask. So basically, Flask is a framework to help to design the website. Okay, in Python. So basically, in Flask, we have a main file which is the app.py file which we have to create. So in the app.py file, we have to define the different routes. Just like this is the one of the route. So this is the homepage route where we are rendering index.html. So all HTML files are there in template folder. So if you go to template folder, there are all HTML files are there. You can go through the code. This is nothing but plain CSS, HTML, CSS. Okay, so I believe you also already aware, and you will found a bunch of tutorials for the HTML and all. Okay, so this way we can create a route. Okay, similarly this is the dashboard route. Okay, this is the index route, this is the home route, this is the about page route. Okay, so we have done all the routing in this app.py. Okay, similarly when user do the registration, we have to create the API. So this is the API. So whenever you register, it will just take all your information. Okay, and it will insert into database. I have created a class, database.py class. Inside that class, I have created all the database operation. Just like insert data, what it is doing, it is accessing the data and inserting into user. So this way we are inserting the data and all. Okay, and similarly login. Okay, whenever do you do the login, you just take the parameter login and sign up and check the credential whether it is exist or not. Okay, so in the rate credential function, we have written the simple SQL query to get the user detail based on email ID and password. Okay, if match, then user will get login or home dashboard. Otherwise, it will get the alert. Okay, so this way we have done all those things. Okay, and also we have here we are loading our staking model, the model which we have trained, hybrid model, which was the highest accuracy. And these are the columns which we are using. Okay, top 20 selected features. Okay, so these are the some functions which I have created for predicting. Okay, so this is the main root, which is predict root. So whenever you put data, so in the columns, so it will just create the dictionary or a data frame of that particular inputted data, and it will do the prediction, and whatever prediction will happen, it will show into dashboard. Okay, similarly when you upload any CSV file, so it come here. Okay, and it decode into the data frame. Okay, and also do the same, kit do the make the prediction and show it to user. Okay, so this way we have done in the front end part, app.py part. Okay, and this is the template folder which consists of all the HTML files. Similarly, this is the static folder which consists style and everything. Okay, this is the notebook folder which basically consists notebooks which I have shared. And the models are there in the data set. All the data sets are there. Okay, in the database, our database is there. Okay, so this way we have done the thing. And whenever you run the project, you will get this URL. So you just have to go to this URL in your browser. Okay, so this way you can uh, run your project and showcase. Okay.
Thank you friends for watching my video. If you are new, then subscribe channel and share with your friend. Thank you.